So thank you for the introduction, and I would like to thank the ISBSG for letting me present this topic today. It's titled Maximizing Customer Satisfaction, Research on Prioritizing Requirements for Optimal Software Releases. And I'm Víctor Pérez-Piqueras. Who am I? Well, I'm a software engineer from Spain. As Paula has said, I'm also a Scrum Master and I'm a PhD student in the University of Castilla-La Mancha. And here you have also my email. And yeah, let's start with the presentation. So what I'm going to talk about in this conference. Well, I'm going to show you a problem we have been working on and doing some research in the last 2 years, and it's focused on using artificial intelligence to solve some of the issues of software engineering, specifically the planning of software releases. So let's start with it. There are many applications of artificial intelligence in the software development lifecycle. For example, there is in the planning. There are many works that address the automatic requirements prioritization. There are also other artificial intelligence tools like ChatGPT or Copilot that you might already know about that automate code generation and for other steps of the lifecycle, like for example in testing. There are many works and tools that allow you to automatically generate test cases or test API. So we are going to focus on the planning step, and we're going to delve into AI applications to automate the requirements prioritization. So how do we do this? Well, the common problem that we might have in the planning is to plan a release and basically define which is the scope that we're going to have for the release. For example, in a classical or waterfall-like approach, we might gather all the requirements of the software we are going to plan into release. We will define all of them, and we will take into account or estimate the effort or the cost of each one of the requirements in order to try to define which requirements will be possible to be implemented given the deadline of the release that we're planning. So for example, for this case, from all the bunch of requirements that we have gathered and analyzed, we will discuss all of them, and we will choose the ones that we think we can fit into the scope. So when we finish the release, we will have implemented, hopefully, all or mostly of the requirements that we have planned. There are other approaches like agile-like, in which we will split the development in smaller steps or sprints or iterations, in which instead of gathering all the requirements, we will gather just a few of them. We will choose or prioritize the ones that we think are more valuable to the customers or stakeholders, and we will implement them. Then we will take the rest of them, keep getting feedback and new requirements, changes, whatever. And again, we will repeat the same process in which we have to select from this list of requirements the ones that we think satisfy more the customers and implement them. But as you may notice, in both waterfall and agile methodologies, we have the same problem. That is to select from a list of requirements the ones that are most important. So what we have read in many previous works in the research is that we can define this formally as a problem that we can solve by means of calculus and mathematical methods. So let's define the problem. We have some software product that we're trying to develop. Then we also have some list of stakeholders, people that are interested in this software being developed. We might also be able to define roughly for each of the stakeholders that we have identified if they are more or less important or the weight that they have for our project. For example, let's say that we identify that we have a user and an investor. And maybe in our use case, in our project, we do care more about the opinion or the interest of a user than our investor. Then we will also have a list of requirements, of course, because we will interact with these stakeholders and identify which are the requirements that will be transformed into features. Apart from this, we will gather feedback on the requirements depending on the stakeholders. For example, the user might be interested in some of the requirements that are, for example, more closely related to UI or to accessibility. And maybe other stakeholders might have different interests. So they will tell you that the importance of some requirements are different. For example, the investor might be more interested in requirements or features related to, for example, payment methods and so on. So there are different stakeholders with different interests in the requirements that we have defined and we are planning to implement. Also, these requirements might be dependent. For example, a requirement might have to be implemented before other can be started. For example, in this case, if we want to implement the requirement 1, we have to implement also requirement 2, because this cannot go without the other one. So we also have to take into account if there are dependent requirements. And lastly, we have to give some cost estimation, usually given by the development team, but could be given by anybody, so that we can estimate which is the cost of each of these requirements. Regarding the cost, here the cost can mean many different variables. Could mean monetary cost, time cost, could also mean sizing like function points, or effort like story points. It depends on the project and the methodology you are using, but depending on the variable that you are using, you will take into account one or another. So in the end, what we are looking for is to find a solution that is a release proposal, a list of requirements that we want to implement that will have some expected satisfaction given the stakeholders and the feedback they gave for each of the requirements. And it will also imply some cost. Here, the cost might mean, as I have said, many different variables, depending on what are you using for the estimation. So if, for example, we want to take care of the cost of the release in terms of money, you should estimate this in terms of cash. And if you're estimating it in function points because you want to evaluate different proposals with regards to function points, then you will use function points. Yep, so given this definition of the problem, in the research, there are many different algorithms that we can develop in order to calculate this. So what is an algorithm going to do? An algorithm will take a problem, in this case, it's our project, with the data of our stakeholders, with our requirements, and with the estimation of cost that we have given for each of the requirements. And this algorithm is going to give us or generate different solutions. Each solution is a release proposal with a set of requirements that are included. Each of these solutions will have a satisfaction and a cost. The satisfaction is basically calculating for each of the requirements that we include how important they are for the customers, and also taking into account if the customers are customers that we really want to take care of. For example, in the previous definition of the problem, there might be requirements that are very important for all the stakeholders, so we might tend to choose those, but there might be other requirements that are not really important for some stakeholders, but might be for others. For example, a requirement related to the UI might be interesting to our user. So if we value the opinion of our user more than the opinion of other stakeholders, we will tend to think that the satisfaction of this requirement is more important than the satisfaction of other requirement that might be more important to other stakeholders, but we don't really care much about that stakeholder. So in order to calculate the satisfaction, we are going to add up all the expected satisfactions of the requirements that we want to choose. And with that, we have the total expected satisfaction of a release. Then we also have the cost, which works in the same way. We are going to add up the cost of each of the requirements that we want to include in whatever variable you are using, and that's the total cost. So here, for example, we have a solution provided by the algorithm that has quite high satisfaction with a very low cost. So the algorithm is going to try to generate new solutions that are very good and are improving previous solutions. For example, comparing the first with the second solution, we might find that the second solution has a very low satisfaction compared to the first one and a higher cost. So we can say that the first solution improves the satisfaction compared to the second one, and it's also better with regards to cost. So this algorithm will choose the solution over the second one. And I will not go deeply into how an algorithm works, but basically doing some calculations, it will tend to choose solutions that are better in satisfaction and cost. So in the end, after running the algorithm, we will find a list of proposals or release proposals that are a set of requirements, in which we will have a combination of proposals that are very costly, but that imply a lot of satisfaction, and others that have a lower cost, but also lower satisfaction. And in this case, you can see that there is no best solution, because depending on your context and your project, you might want to choose a solution with a higher cost, but higher satisfaction, or a lower one. It depends on your budget and your scope. But the algorithm will give you a full list, so you can choose among these. So, given the algorithm definition that they have explained, there is a lack of datasets in the research field in order to evaluate these algorithms, because we need to provide different datasets so the algorithm can be run, executed, and evaluated, so that we can assess that one algorithm provides better solutions than others. So what's a dataset in this case? Well, a dataset is our project, basically. So we have our list of requirements, and each requirement, as I have explained, has a numeric cost. And as I say here, the cost could be person days, money, sizing, inflection points, effort, whatever value you want to use in order to select one or another solution. Then for each requirement, we're going to have also the stakeholders. The stakeholders, as I said previously, are going to be evaluated or given an estimation of how important they are. For example, we might say stakeholder 1 is very important for us, and another stakeholder might be less important. We can transform this into numeric values, for example, following a range of 1 to 5. So the first stakeholder is very important, we might give it a 5, and other stakeholder might be less important, we can give it a 3, for example. So with this, we are transforming into numeric values the estimation of the importance of each of the stakeholders. Then I also said that we are going to provide the requirements to the stakeholders to get some feedback. So each stakeholder is going to tell us for each of the requirements if they think it is relevant or not. So following the same procedure, we give a range of 1 to 5. So if the stakeholder 1 says that the requirement 1 is very important, we will put it at 5. The other stakeholder told us that it was not so relevant, but still, so it's a 4. And we keep doing this for all the requirements. So maybe there are another that is not so relevant or not relevant at all for the first stakeholder, so we give it a 1. And we keep doing this for all the stakeholders and all the requirements. And this is basically the structure of a dataset. So that we have transformed the subjective values into numeric values and arrays that we can use in order to run some calculations with these algorithms that I have introduced. But as I have said, we have not so many datasets because usually companies do not provide them due to privacy policies. So we have to generate them, but to create some synthetic datasets. So for that, in our research, what we have done is to generate randomly the stakeholders with their associated weights. So we just generate a list of stakeholders and generate some random values of how relevant they are. Then we are also going to generate some list of requirements for this dataset. And for each stakeholder, we are going to also generate random values so that each stakeholder puts for each requirement a random value between 1 and 5. And regarding the costs, of course, as this is the component of the ISBSG, we are using the ISB dataset. In this case, it's the version of 2015 because it's the only one that we have at the moment. and was provided by my supervisor. So as this was the one that we had, this is the one that we used. And in this case, we used as development type for the package the new development. And we also filter the data by the count approach of if put for plus. And in order to generate this bunch of cost for each of the requirements, what we're going to do is to obtain the percentile 75 of the total function points. And we're going to generate randomly one cost for each of the requirements until the sum of all the requirements adds up to this percentile. And this is the way that we have designed in order to generate randomly data sets taking into account real data. So even if they are not specifically from real projects, we're using real data in order to simulate them. And this data set generation was published in a Q1 journal some time ago. And if you're interested in it, you can check it out. And there we explain roughly what we have explained here about how we generate datasets. And this is how we generate dataset. And with this, we can evaluate our algorithms and check which of them are better in order to generate some release plan proposals. But this is very not very interesting in paper, but the good part of this would be to bring it to the real world. So in this case, I'm going to show you, a tool that we have developed in my PhD thesis, which is integrating these algorithms into a software tool that we're going to see once I open it in the browser. Okay, I hope you still see it. Okay, so this is a web tool that we have developed, and basically it's a project management tool. So basically you can configure different projects and you can manage them, have a team, and the classical data that you might see in some other project management tools. But the interesting part is that this tool allows us to basically introduce all the data that I have shown in this presentation. So for example, we can define our stakeholders in the tool. So here in the team, we can identify for each of the stakeholders how important they are. Then we also have a product backlog in which we can create the requirements. And for each of the requirements, we can, on the one side, give some estimation. In the case of this tool, we are using story points as effort, but depending on your project, you could use just any other value. So we have the estimation of the cost for each of the requirements, as you can see here in these numbers. And also in the project, we can offer these requirements to the stakeholders, which can log in into the project, into the tool. And for each of the requirements, give a value or importance of how important they think these requirements are. So for example, in this case, we have 3 stakeholders. One is a user. The user said that doesn't care about this requirement. It's upgrading the UI framework. There are also 2 other stakeholders that are the investor and the customer that think that this requirement is very important. So we can store this data in the tool. And with this, we have basically the structure that I have explained regarding dataset in the tool. Now, we have to obtain some release proposal with the algorithms that I have explained. For that, we have designed a module over here in which you can select one of the many algorithms that we have tried and experimented with in our research, and you can run the search. What this is going to do in the background is going to take all the project data that you have in your backlog with regards to your stakeholders, your requirements, your cost, and the importances, and it's going to calculate all the solutions that are optimal with regards to the problem. So we'll try to find solutions that are the best given the cost. For example, in this case, we have a range of solutions from cheaper solutions to more costly solutions. And these algorithms are trying to find solutions that, given, for example, this effort, there is no solution with this effort that provides a higher value. So you don't have to bother playing with the numbers and with the requirements, trying to find which requirements should you add or remove in order to improve the value or the satisfaction that you're expecting give to the stakeholders, the algorithm is going to do it automatically for you. So you can just go and start navigating to the proposals obtained by the algorithm. And here on the right, you will see the requirements that are being proposed. So in this case, we can see that the algorithm, for a cost of 50 story points, is proposing to implement all of the requirements except for this one. And why the algorithm left this one out? Probably because in this case, the stakeholder that is most important for us, that is the user, provided a value of 0 to this requirement. It said it's not important at all. So the algorithm is considering that this requirement is the less important for us. So in the release, we will leave it out. In the case that in our release, we expect to have a lower development advance, for example, to 20 to 30 story points burned until we finish the release, we can find other solutions that have a lower satisfaction. In this case, we click on this one and we can see that there are less requirements included, but of course we are putting a lower budget. So it's obvious that there are going to be less requirements or cheaper requirements. And apart from that, we can also see here an interesting panel in which we can see that there are stakeholders' satisfaction or interest depending on what we have selected. So if we want to satisfy some stakeholders more than others, we can navigate through these solutions to see if the stakeholders are being satisfied or not by these proposals. So this tool is not expected to give you the best solution possible, but is expected to at least be a starting point for discussion. So it might not be the 100% best solution for your project, but at least it's going to help you with finding solutions that are not optimal, but close to optimal without having to do some of the calculations manually. So it will help you reduce the time that you will take. And this is for a project in which we have few requirements, but if, for example, I open this other project in which we have like 20 requirements, and you might have even more in your projects, by running the algorithm, you will see that there are quite a lot of possible solutions. So it might be difficult to do this manually. For example, in this case, you can see that we have a lot of possible solutions. And these are the best ones found by the algorithm. But below these ones, there are others that are not optimal. And the algorithm is providing you the best ones. So we can navigate them and we can find which is the algorithm considering to leave out of the release. For example, we can navigate one of two, and we can see that the algorithm already provides you the sorting so that you can include this in the release and leave these others out. And that's basically the tool that we have developed. So I will go back to the presentation. So I had here some demo in case the application failed for some random reason, but as I could explain you leave, which I think it's more interactive, we can skip it. So that was it. Let's check the conclusions of this work that we have developed. So first of all, we have identified that the release planning is candidate to be automated by algorithms, as we have seen in previous works and in the ones that we have carried out. Also, we have found out that the solutions are not always definitive, but at least can be a good starting point for discussion, or just in order to not consider 100 possible solutions, but 2 or 3. Also, the data is really important in order to carry out the research, because we cannot evaluate algorithms if we don't have data in order to evaluate them. So it's quite important and was quite useful to be able to use the ISBSG data and to have available data sets in order to carry out these experiments. And lastly, the algorithms are only useful if they can be applied in real world scenarios. So that's why I showed you this tool that I have developed, because we believe that the algorithms are very interesting, but if you cannot bring them to actual decision makers to use them, they are useless. And lastly, as open questions that I will leave for you, if you have some ideas about them, we'll give this to: how could we improve the dataset generation process? So in future research, we improve it and do it in a better way with more quality. And also how to simplify the application for the end user, because there might be a lot of improvements that we can apply so that the users find it easier and they can plan software releases more successfully. And that was all. So we'll be open to any of the questions that you might have. And you have also here my contact by email or LinkedIn or GitHub. So if you want to write me some email with some other question that you might have and you couldn't write it now, then I'm open to it. So thank you very much.
Thanks, Victor. That was great, especially seeing your application live. That was great. We have a question from Kuprananda. At what level of granularity shall the requirements be handled?
Okay, yeah. In this case, as with the cost estimation that I have explained, it depends totally on your project and how you're going to handle it. So if you're going to estimate the requirements on a higher level, then you will define the requirements at a higher level. So we are considering here release planning. So you could use higher level requirements, but if you are also estimating the requirements at a lower level, then of course you can refine the requirements, transform them into lower level, and use the tool to plan them. So of course, if you have a possibility to define the requirements at a lower level and get the feedback from the stakeholders, which is usually a critical step, then will be better to use that data because it's more granular. But sometimes you cannot give a stakeholder, ask the stakeholder to estimate like 100 small requirements, but just a bunch of bigger ones. So if you cannot do that, then it's fine also to use higher level requirements. Hope it answered the question.
Yeah, I think so. Thank you. I'm interested too, because with your tool, you put story points in there. Do you have flexibility on other sizing methods?
Yeah, for the case of this tool, it's just story points, but I think it couldn't be an issue to just change the implementation to allow other estimation. So in this case, we have a range, typical Fibonacci range of values, but as I explained, by changing it to some normal input field that you can put whatever number, could be story points, hours, money, function points. So it's open. I mean, the algorithm is going to work anyway with whatever number you pass, as long as you take into account that the estimation or the cost that you are putting is what you are going also to use when you get the results to select one or another release proposal.
Okay, thank you.